Welcome back, pre-calculus students. Today we're going to be looking at a process called expansion. We've seen basic expansions previously with things like a plus b squared. Obviously that's not too difficult. Today we're going to kind of get a little bit crazier and see what happens when this 2 turns into numbers like 4, 7, even as high as something like 15 we can tackle. In order to do this, the first thing we need to understand is what Pascal's triangle is. A lot of you may have studied Pascal's triangle in the past. If you have, that'll be great. If not, here's how it's generated. To figure out each term in Pascal's triangle is generated by adding the numbers in the previous row. Now that's a bit simplistic, but it's the basic explanation. Works like this. First number is always 1. The next row is always 1, 1. Now what we're going to do is add 1 plus 1 to get 2. On the outside still 1. 1, 3. 1 plus 2 is 3. 2 plus 1 is 3. 1. It keeps on going. What's important to know is when you start counting, in Pascal's triangle, this is called row 0. This is row 1, row 2, row 3, and the diagonals also start at diagonal 0. Diagonal 0, diagonal 1, diagonal 2, and so on and so forth. Pascal's triangle is indefinite. It goes on forever. Just as long as you're following the 2 patterns, then whenever you're adding 2 numbers, you get the 1 below it. In order to expand a plus b to the end using Pascal's triangle, now this is one process, there's another way of doing it, but this is the first one. The coefficients will be in the nth row of Pascal's triangle. All that means is whatever you're expanding it to, you go to that row. Remember, it starts counting at row 0. The exponents of the first term begin at n and decrease, while the exponents on the second term, b, will begin at 0 and increase. And typically what may be helpful is if you rewrite a minus b and you think of it as a plus negative b, or the opposite of b. You're going to see why when we get to a couple practice examples.